Okay, good morning, guys. Assalamu alaikum, guys. Welcome back to grade 12 mathematics by Inspired Teens, bright and early on a Saturday morning. I hope that you guys are keeping well. In today's lesson, we are going to continue with trigonometry. We are going to do in terms of questions and hopefully get to trig identities. Okay, just to recap what we've done in the previous weeks. We started off with the basics of trigonometry. We went into reduction. Okay, we completed reduction. We did special angles. Okay, then some revision of reciprocals. Okay, special angles, and then we moved on to Cartesian plane questions. So we solved Cartesian / Pythagoras questions, and now it's time for us to do in terms of questions, right? So let's get into it. So in terms of questions and Cartesian plane questions, both are solved without a calculator, okay? And both are solved with a diagram, okay? So it is important to understand how to solve these questions as well as to be able to distinguish between these two questions. So Cartesian plane and in terms of questions, okay? How do we distinguish between them? So it's pretty simple, okay? Oftentimes, right, the first way to distinguish between a Cartesian plane question is, so let's read this question. It says, if 3 sine theta minus 2 is equal to 0 and tangent theta is less than 0, determine the value of sine squared theta plus cos squared theta without using a calculator and by using a diagram. So you'll notice that both type of questions mention without using a calculator. And remember, I said in the last lesson, sometimes they'll say without a calculator and using a diagram. Sometimes they'll mention just one of them. Okay, but both of them indicate we need to use a Cartesian plane. Okay, so sorry, we need to use a diagram, or we're going to solve it without a calculator. Okay, then if we go to in terms of, let's look at the question. They'll say, given sine 44 is equal to k, without the use of a calculator, determine the following in terms of k. Okay, so that's the key. So as you can see, what distinguishes this question is this in terms of, it's also highlighted, right? Because it says in terms of k. That's the important part. That's why it's labeled as the in terms of questions. Okay, so that's the main identifier for in terms of, there's other things you can take note of. In this case, you always have the angle, okay, and it will be equal to a variable. So you won't know the value of sine. They're not going to give it in terms of values, okay? They're going to give it in terms of variables, okay? In this case, they gave it in terms of k. So that's another key identifier. And with regards to Cartesian plane questions, you'll notice that they give you clues as to which quadrant you're going to have to draw it in. Okay, for example, this, you won't find that extra bit of information in terms of question because it's not needed. Okay, so that's an identifier. But yeah, the main thing is in terms of questions, you're looking for the keywords in terms of k or in terms of whatever variable they give you. That's how you know you're solving it in terms of question. And of course, today we're going to learn how to solve those questions and how they differ from Cartesian plane questions. So Cartesian plane questions, we covered them last week and we covered how to solve them. Okay, you have to draw up your Cartesian plane. You have to determine which quadrant you're in, draw a triangle, fill in your triangle. Okay, and then complete the triangle using Pythagoras. Okay, be aware of negatives and positives depending where you are in your Cartesian plane, right? Be aware of positive and negative x and y values. Okay, and then yeah, okay, and then you solve for whatever they want you to solve for. Okay, so now let's look at in terms of questions. They say, given that sine 44 is equal to k without the use of a calculator, determine the following in terms of k. So the thing for in terms of questions is you always need to note that you are going to draw a triangle. It's not going to be in a Cartesian plane, it's just going to be a triangle. Okay, you are given the angle, and here you actually know the value of sine. Okay, remember that sine. Remember that sine is opposite over hypotenuse. Okay, sine is opposite over hypotenuse. So since sine, let's work in blue. So since sine is opposite over hypotenuse, we actually have the value because any value that's not a fraction, okay, that can be written as a fraction just over 1. So the value of sine, in this case, opposite over hypotenuse, is k over 1. Okay, so just keep that in mind here. Remember, sohkatoa, right? That's the key here. Sohkatoa, telling us what? Telling us that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so in that case, we have the opposite and our hypotenuse. So again, if you give anything just it's equal to k, please keep in mind k over 1. That would be the value of your opposite, k, and your hypotenuse, 1. Okay, and now you can fill this piece of information into a triangle. Okay, so let's do that. Let's maybe move our triangle a bit closer. Okay, and firstly, it's going to be a perpendicular triangle because that's where we can use our trigonometric ratios, sine, cos, and tan. They can be used in a perpendicular triangle. I'm going to fill in the only angle that's given to me, 44. Now, this diagram does not have to be drawn to scale, so no angles have to be perfect, right? The angles don't even have to look accurate. You just need to draw a perpendicular triangle and fill in your angles, okay? So this is the angle that was given to me, sine 44. Okay, so again, remember, sine is opposite over hypotenuse. So the values of the opposite to 44 and the hypotenuse of the triangle I have in terms of k and 1. So opposite is k. Let's fill that in. And hypotenuse is 1. Okay, so sine 44 opposite over hypotenuse is equal to k over 1. Okay, now the next thing you need to do is complete the triangle in terms of angles and in terms of sides, both of those, right? Angles and sides. So how do we solve for the angle? Remember, the angles of the triangle need to add up to 180 degrees. So 180 minus 90 minus 44, that should give me an answer of 46 degrees. So my third angle here is 46 degrees. Again, you're going to do this every single time. You're going to fill out all the information. Then the sides, okay, remember this is a 90-degree triangle, so we can use Pythagoras theorem. So Pythagoras theorem is hypotenuse squared is equal to the opposite squared plus the adjacent squared. What are we going to leave alone here? We don't have the adjacent because we can work with 44. So the adjacent squared, okay, it's equal to the hypotenuse squared plus the opposite squareds. We can minus, that's the key thing. Don't ever forget that. Don't make that mistake that I just made. Hypotenuse squared minus opposite squared. Okay, so we square root both sides. We're going to get the adjacent being equal to the square root of hypotenuse is 1 squared minus the opposite is k, so k squared. If we simplify this, the adjacent is equal to the square root of 1 minus k squared. Please do not think that you can square root this and simplify it to, this is not equal to, let's do it in red. This is not equal to square root. I don't know, maybe some people might say because you can square root 1 and square root the k squared. This is not equal to square root 1 minus k. Sorry, not square root 1 minus k, just 1 minus k. If you want to square root the whole thing and say, oh, square root of this is 1 minus k, because you square root 1, you square root k squared, you get 1 minus squared. This is completely incorrect. Why is this incorrect? Because of this little negative sign here. Okay, you cannot just square root over a positive, a plus or a minus. Okay, you have to like square root this whole thing, and we cannot do that. So the simplest form is this. Okay, remember there's rules to square rooting, right? If it was multiplication, for example, square root 1 times k squared, this is a different story. Then yes, you could square root 1 and square root k squared in that case. Okay, just keep that in mind. Okay, for maybe some of you who might have thought you could simplify to that, you cannot. This is the final answer you should simplify it to. Now you should get so used to these triangle in terms of questions, there should not be the need, okay, to do all of the steps. You should be able to look at this, okay, understand that in Pythagoras' theorem, all terms are squared. Oops. All terms are squared. Okay, so no matter which one you make the subject of the formula, to get that value, you're going to have to square root both sides. For example, if I wanted hypotenuse, I would have to square root both sides. So then I solve for hypotenuse. Okay, and it's going to be the square root of opposite squared plus adjacent squared. Okay, so your answer here, because it's in terms of variables, is going to have a square root. Okay, that's for sure. Now, this is the adjacent. Okay, and you should be used to Pythag at this point in time to understand that hypotenuse is equal to the sum of opposite and adjacent. But if you want to get adjacent, it's going to be hypotenuse squared minus opposite squared. And if you want to get opposite, it's going to be hypotenuse squared minus adjacent squared. Okay, so that's that minus component in there. So in this case, I'm going to take 1 squared and minus k squared. 1 squared is just 1. K squared can be simplified to just k squared. Okay, that's easy, it's simplest form. Okay, so you shouldn't be doing Pythag. You should be able to do this. You should be able to solve this quickly. Just be able to write it out, just using the logic. Okay, but if you cannot, that's why we have this in place. So you can actually just Pythag it. Okay, just keep that in mind. So now we've completed the triangle in terms of angles and in terms of sides. Okay, I hope that you guys understand that. Please, if you guys have any questions, please ask them. Okay, let me just make sure chat is working. Okay, sure. Okay, so that's what it simplifies to. That's what this is the adjacent. Okay, the adjacent to 44, but actually opposite to 46. Now let's go ahead and attack the questions. Okay, now you see this here, given blah 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 without the in terms of k, again another keyword or same keyword that we've been working with in terms of k. So our answers for all of these in terms of questions, we're not going to get a final value. We're not going to have like, okay, the answer is 5 or the answer is 7 or the answer is root 3 over 2. We're not going to get it in just a number. They're all going to be in terms of k. So our answers are going to have variables, which is perfectly fine. Okay, because we don't know the value, we want to answer it in terms of k, and that's perfect. Okay, so let's look at sine 46. Okay, remember that sine is opposite over hypotenuse. Okay, sohka toa. Okay, so opposite of hypotenuse, where do we get this value for opposite? Where do we get this value for hypotenuse? That is where we turn to our diagram. Okay, so we go to the angle of 46, and what do? We look for its opposite and its hypotenuse. Its opposite is root 1 minus k squared, and its hypotenuse is 1. So that's going to be our answer. This over that. Okay, because again, this is we're working with 46. So you see the first question already wasn't working with 44. The angle that was given was working with 46. So that's why we should complete the angles of the triangle so that we can visually see, oh, that's where 46 is. Okay, it's in our triangle, so we can work with it. So opposite over hypotenuse. So it's going to be root 1 minus k squared over 1. So this is equal to root 1 minus k squared . 1 minus k squared over 1. Okay, so of course, then that just simplifies to root 1 minus k squared. Okay, hope that makes sense. And that's our final answer because, again, it's in terms of variables. Now, let's have a look at cos 224. Okay, so firstly, cos 224, the angle 224 is, of course, not in our triangle. So this is not going to be a straightforward answer. You can't just simply say sine 224 or cos 224 or tangent, okay? Because we don't have that value in the triangle. So that's where these steps come in on the right. I've written a few steps, which are basically amazing. Okay, I'll tell you why. Because they cover any type of question that they can ask in terms of questions. Okay, any type of question that they can throw at you here. Okay, okay, you'd be able to solve utilizing these steps here. Okay, so as you can see that none of them are simple. They're all complicated angles. So there's going to have to be some sort of simplification, perhaps like reduction or other things, which we'll get into. Okay, simplification before we there has to be some sort of simplification before we actually can get to an answer. Okay, because again, none of these angles are in the triangle. None of these angles are straightforward in this triangle. In the triangle, we only have 44 and 46. Okay, that was easy for the first one because they asked sine 46. They could have asked sine or cos 44, tangent sine or cos 46, right? They could have asked any of those. Those would be easy to answer once we have the triangle. So with these complicated ones, there is some simplification that needs to take place, and that's what this helps with. How do you simplify this before you can get to your answer? So the first step, you should do it in this order, right? You should always try to see if you can do reduction with the angles of the triangle. Okay, reduction with the angles of the triangle. So what does that mean? That simply means that you want to reduce. Remember, our reduction angles start at 90. Then we can do a reduction with 180. Then we can do a reduction with 270. Then we can do a reduction with 360, right? So that's how we can reduce. Then our reduction angle looks something like 90 minus 36 or something, you know. So you can reduce in that manner. And what we want to try and do is try and reduce with one of the angles of the triangle. That's what this is saying. Reduction with the angles of the triangle. So in this case, you want to try and relate one of the angles in the triangle with a reduction angle to either, when you add them or subtract them, get you to 224. So let's try it, right? So the two options that you have for 224 with reduction are the closest reduction angles to it. So the lower one is 180 degrees and the higher one is 270 degrees, right? So those are the two options for reduction that I have. So what I want to try and do is I want to try to get from 180 to 224 or 270 to 224 using one of the angles of the triangle. So I'm actually going to grab a calculator. 1 second. Okay, and I'm going to try and say, okay, let's see, 224 minus 180, and I get 44. So 224 minus 180 gets me to 44. So I can actually work with that. Instead of having cos 224, I can represent this with cos 180 plus 44. Okay, I hope you guys are seeing how that works. I haven't changed the value of this term because 180 plus 44 is still 224. However, I've written it in terms of a reduction angle, so now I can reduce it. And I didn't just write it in terms of any reduction angle. It was written in terms of a reduction angle with one of the angles of the triangle. So that obviously I can go back to try and relate it to the triangle. Okay. So now in this case, I have, what do I have? I have cos 180 plus 44. Let's reduce this guy. 180 plus is in the third quadrant where cos is negative. So this becomes basically negative cos 44. Okay. Negative cos 44. I go to my diagram now and see, remember that cos is adjacent over hypotenuse. So toa. So I go to 44 specifically, and I look for its adjacent and its hypotenuse. So its adjacent is square root 1 minus k squared. Its hypotenuse is 1. So that's a simple answer of negative. So just keep in mind the negative because that we got from reduction. 1 minus k squared divided by 1, which simplifies to negative square root 1 minus k squared, right? Remember this 1 minus k squared is inside of the third. Okay, so I hope that makes sense. Again, stop me if you don't understand or if you have any questions, but that's simple reduction. You could do the same thing with 270. Just keep in mind that when you simplify with 2, so in this case, you'd actually have to say 270 minus, it actually becomes minus 46, and then you'd have to work with 46. Just keep in mind with 270, sine would change to cos, cos would change to sine. Okay, those rules, of course, still apply. This is like regular reduction. Okay, let's look at tangent squared 134. So let's try the first step again, a reduction with angles of the triangle. So remember, with 134, I can reduce with not 90, only 180. Why? Because remember, with tangent, you cannot use 90 and 270 because those are the asymptotes on the tangent graph. So those values are undefined, and you simply cannot reduce tangent with 90 or 270. So my only option is 180. So I say 180 minus 34 to check what that actually gives me. 180 minus 134. And this gives me a value of 46. And this is an angle inside of my triangle. So I can change this to, without changing its value, can re-express it as tangent squared 180 degrees minus 46. Okay, now I've written it in terms of its reduction angle. I haven't changed its value, but now I can simply reduce it. Okay, so remember this tangent squared. If I'm not mistaken, we did examples with square, right? And how the squared does not make you cannot get a negative from the reduction of a squared trigonometric ratio. okay, a trigonometric function. So in this case, the reduction itself cannot make it negative. If there was a pre-existing negative before it, that's fine, that would stay. But when you reduce it, it doesn't matter which quadrant it's in. The result of its reduction is always positive. Okay, so in this case, tangent is 180 minus tangent is negative, but it doesn't matter because it's squared. So this reduces to tangent squared 46. Okay, now this square you need to keep in mind, it can literally just be written as tangent 46 tangent 46 squared like this. Okay, that's the same thing. So whatever your value for tangent 46 is, you just square that answer to get your final answer. So let's do that. Tangent 46. Let's go to our triangle. Tangent is towa, opposite over adjacent. So we go to 46, we look for its opposite, we look for its adjacent, and boom, we have the answer. It's going to be square root 1 minus k squared over k, and then squared of that answer. Square root 1 minus k squared over k squared. Okay, now if you remember correctly, when it comes to, this is an exponent rule, when it comes to squaring a fraction, to simplify it, you basically find the square value of each, the numerator and denominator. Okay, so that's exactly what we're going to do. When I square the numerator, okay, let's do it step by step, I guess. 1 minus k squared squared. In this case, what then happens is, excuse me, what then happens is the square root cancels with the square. Okay, and then we have at the bottom k squared. And finally, of course, you don't have to write all these steps. I'm just simplifying it. We're left with 1 minus k squared divided by k squared. And then, of course, k squared and k squared cancels. Nope, that would not happen. If you cancel k squared and k squared, that's really terrible. Okay, the reason you cannot cancel them is because of this negative, right? Please, please, please keep that in mind. Can you only, whenever you have like a fraction like this, you can only cancel like this if you are canceling terms across a multiplication. So if there's only multiplication, for example, then you can just cancel. But when there's this negative, you'd have to have something to cancel this whole thing with the negative. Okay, you cannot just cancel one term of a negative. Okay, so this is actually the final answer. Okay, done. So I hope that makes sense. So we solved two of them using this first method already, right? It's quite common. Okay, reduction with angles of the triangle. Okay, so just keep that in mind. Let's move over to the next one. Okay, and this next one says cos 88. Okay, so again, we try the first method, reduction with angles of the triangle. So naturally, I have cos, the closest one to cos is actually only 90. I can only reduce cos with 90, right? I can't use 180, it's a bit too far. So when I reduce it, obviously to get from 88 to 90, this would have to be cos 80, sorry, cos 90 minus 2, which would then simplify to sine 2. Now the angle 2 is not in the triangle. It's a very strange angle to get actually, okay? So in this case, this is when reduction actually doesn't work, reduction with the angles, triangles, the angles of the triangles. Reduction in this case specifically does not work. Okay, so we rule this one out, and now we can start moving on to the next one. So again, you should, for in the exam when you're doing your question, you should already have these in mind. You should have these 4 things by hearted that you can try these 4 steps in order to simplify these questions. You might, most of the time, you're not going to get like all examples. You're probably going to get 2, and you could literally just get 2 simple examples and then move on. Okay, but the potential for getting any one of these is there, right? There is a possibility to get any one of these. So yes, you try reduction with angles of triangle, it doesn't work. So then you try the next one. Let's try double angles. So what do I mean by double angles? You try to see if the angle that you are given, okay, is double one of the angles of the triangle. So you try to see, is 88 double of 46 or is it double of 44? And you'll be like, oh yes, 86 is indeed double of 44. Okay, so now let's re-express it. The way we re-express this okay, is cos 88 is equal to cos 2 times 44. Okay, I haven't changed the value. I haven't changed the value of the term because 2 times 44 is still 88. It's still the angle inside for cos. Okay. However, I've expressed it slightly differently in terms of a double angle. Now, I know we haven't done identities as yet, but we will, I'm sure that most of you have definitely covered it in school by now. So we will just quickly go through these, right? You need to remember that with double angles, it's something new that you guys have learned in grade 12, right? It's newly introduced. So cos 2x can be simplified, right, in one of three ways. 2 cos squared minus 1, 1 minus 2 sine squared, and cos squared minus sine squared x. So again, we'll go through this in more detail when we do identities, okay? But for now, we're just going to use like this one here, okay? 2 cos squared x minus 1. So we're just going to simplify. We need to just remember that cos 2x can be written as 2 cos squared x minus 1. Okay, that's the one that we'll use. The main thing here is obviously not learning the double angles, but learning how to implement double angles in these in terms of questions. So in this case, cos 88 can be simplified to cos 44. Now remember, we said we have cos 2x. This can be simplified to 2 cos squared x minus 1. So the key thing here is you went from 2x to x. That's a lot of the time why you use, that's actually the only reason why you use double angles, because you want to express it in terms of this x angle and not double of it, which is exactly our scenario here. We want to express this in terms of 44, not 88, right? We want to get back to x instead of 2x. So utilizing this, I can simplify this guy to 2 cos squared, okay, x, which is half of 2x. So 2 cos squared 44 minus 1. And now I haven't changed the value of it. I've simply used an identity to represent it differently. I have it in terms of 44 and not in terms of 88. Now 44, that's good because that's an angle of the triangle. So I can work with that. So again, remember, this here is the same thing as having 2 cos 44 squared, okay, minus 1. So in that case, I can just substitute the value of cos 44. Remember that cos is adjacent over hypotenuse. 44, it's adjacent, it's hypotenuse. Square root 1 minus k squared over 1. So instead of writing over 1, I know that it's square root 1 minus k squared. It's going to be the same. So I'm just going to write 1 square root of 1 minus k squared. And we're going to take that and square it and subtract 1. To simplify this, I'm going to have this is going to cancel. The square is going to cancel with the square root. And I'm going to have 2 open brackets 1 minus k squared minus 1, which simplifies to, if I distribute this guy, okay, when you distribute it, then you should get 2 minus 2k squared minus 1, which further finally simplifies to 2 minus 1 is 1, 1 minus 2k squared. And that's your final answer. So again, as you can see, there's no value. Okay, we're just simplifying our answer down to the simplest form in terms of k. So 1 minus 2k squared, or even if you had minus 2k squared plus 1, same thing. But that's how you solve it. Okay, so again, hope that this is making sense and it's adding up, right? This again, it's what you call it in terms of question, but just utilizing the double angle identity in order to simplify that. Okay, then we have sine 91. Okay, so sine 91, it's the next example. So here we practiced the double angles. Here we practiced reduction, and here we just practiced just the basic first way to answer it. Okay, sorry, just give me 1 second. I'll be back in like a minute. Just give me 1 second. I apologize. Okay, all good. I'm back. Let's continue. So sine 91. Okay, let's try the first step, which is we try reduction. Okay, so sine 91, our options are 90 or 180. So you can already kind of see that this is not going to work, right? Because it's either going to be 90 plus 1, okay, and then it's going to reduce to an angle with 1, which is not in our triangle, or it's going to be 180 degrees minus 89, which again doesn't work, okay? So in that case, reduction is not going to work. What about double angles, right? Is 91 2 times 46? 2 times 46, nope, that's 92, very close. 44 times 2, that's 88. So 91 is not the double angle for any of it, right? So what can we try next? Let's move on to the next example. So we did an example with this, with this. Let's try this now, okay? Subtract the angles of the triangle. Okay, I don't think that works either, but it's fine. Shucks, I forgot to put in one example. Okay, that's fine. I'll just put it in now. Let's do it. Let's do it here. We'll call it A, B, C, D, E, F, G, E, F, G. Let's call it example G. Let's say they want the value of sin 2. Okay. Okay. So we're gonna, I know G is G, but we're gonna do it first because it's in this order. Subtract the angles of the triangle, and if you get something like sine 2, in this is the example where you would subtract the angles of the triangle. Okay, so you say 46 minus 44, and I'll show you how to simplify it, right? So 46 minus 44, so you would express this as sine. Again, you would try the first two don't work, and this is where you turn to this option, 46 minus 44. Now this is no reduction. Okay, this is not a reduction angle because there's no 90 or 180 or 270 or 360. This is just you subtracting these two angles, right? But how does it work? It's actually a concept that you've learned in grade 12. Well, you at least should have learned by now, called compound angles. Okay, so again, if I do the compound angle and you confuse how it works, don't worry too much because we are still going to get to compound angles. But okay, most of you should have seen this by now. It should be at least somewhat familiar to you. Okay, these formulas of compound angles. Okay, so this is actually what we're going to use to simplify this guy. Okay, so we have 46 minus 44. Again, that's not some type of reduction, so we need a different way to solve it, and we use compound angles. So I'm not going to go into the details of compound angles, but when you simplify this with compound angles, you would get the following. You'd get sine 46 times cos 44 minus cos 46 times sine 44. Okay, and then you simplify it. So this one gets a bit more complicated, as you can see, right? It's no longer just simple reduction. It's no longer just sorry, this one is even just straight from the triangle. It's no longer simple reduction. It's no longer double angle. Okay, now it's getting into subtracting the angles of the triangle and compound angles, which is complicated. Okay, but nevertheless, they can ask this type of question. If you have sine 2, how would you solve it? Again, you would try step 1 wouldn't work, step 2 wouldn't work, and step 3 finally works. When you subtract the angles of the triangle, you get 2. So you say 46 minus 44, that's going to give me sine 2. I haven't changed the value of 2, okay, but I can simplify this using compound angles, and this is what I get when I simplify it using compound angles. Now, all of these individual values I can get from the triangle. Sine 46, cos 44, cos 46, sine 44. I can get all of this from the triangle. I'm just going to copy a triangle here so we don't have to keep going up. Okay, I can get all of these values from the triangle. So let's do that. Sine 46 is opposite over hypotenuse. So sine 46 is 1 minus k squared over 1. Cos 44, 44 adjacent over hypotenuse. It's the same as sine 46. So it is this 1 minus k squared over 1 minus cos sine 46. Cos 46 is adjacent over hypotenuse. It's basically k over 1 times sine 44, which is also k over 1. Now let's get into simplifying this. Okay, when you multiply, you should remember this from surd rules. Surd A times surd B, your answer here, okay, is equal to the square root of A times B. Okay, whenever you have two different surds multiplied by each other, you can simplify to one surd and multiply whatever was in each surd. So in this case, this basically would become the square root of 1 minus k times 1 minus k, which is basically 1 minus k squared. Okay, you're multiplying this, and it gives you 1 minus k squared. Okay, 1 minus k squared, and it's 1 minus k squared. Okay, if you don't understand that shortcut, let me know. And then the square cancels with the square. Remember, this is all over 1. It doesn't really matter because over 1 is the same thing as whatever the numerator is. So I get rid of the 1. Okay. And then in this case, I get k times k. Okay, because how do you multiply fractions? Numerator by numerator, denominator by denominator. So I get k squared. So let's just rewrite this. It's 1 minus k squared, which is equal to 1 minus 2k squared. And that's our final answer. Okay, so a bit more on the complicated end, but nevertheless, it's not too bad, right? Once you get the gist of it, when we get in some practices, it's not too bad, provided also you don't mess up the algebra, right? Take it step by step to ensure that you don't make a silly mistake when in simplifying it. So you get the complicated part, but then you can potentially make a mistake with the algebra. It's not ideal. Okay, so avoid that. So yes, that's reduction with angles of triangle, double angled, subtractions of angles with triangles. So you try 46 minus 44. Again, like I said in the start, these are covering every single possibility that they could ask you here, right? They're not always going to ask all four. A lot of the times it's simple, easier ones, like more towards these first 2 or 3, right? And then perhaps they'll throw in sometimes one of these. Okay, and you do your example, get in some practice. But yeah, again, like I said, this is covering all possibilities that they could ask you. Okay, so we've done first 3 examples. Let's look at this one. So this one we tried, reduction doesn't work, double angle, not possible, subtraction of angles doesn't work. Let's have a look at the last and final possibility, subtract or add. So remember, this was subtract angles of triangle. It wasn't add because you cannot add them, right? That doesn't work. Okay, you cannot add the angles of the triangle because you get 90. 44 plus 46, you're going to get 90. And in that case, all right, it doesn't work. So, because obviously if they gave it to you as like sine 90, you know this answer. This is something you should know. You can it's from the graph. Okay, that's like a special angle sort of, and you can put that in your calculator, right? So it's no use saying 44 plus 46 and then simplifying it using compound angles. Okay. So yeah, just subtraction of angles in triangle. But the last one is when you subtract or add angles of the triangle with special angles. Okay, so let's do an example of this. So now we can use special angles as well. So let's do an example of this, right? What you want to do is basically, right? Remember your special angles are what? 30, 45, 60. Okay, those are your special angles. 30, 45, and 60. Am I missing anything? I don't think so. Then of course, like 90 and those ones, okay, but those are the ones you reduce with. Okay, here we're going to add or subtract one of the triangles angles with a special angle. So 30, 45, and 60. We're going to try and get right 91 by either subtracting or adding anything to each other. So now you want to try, right? Let's just say 60 plus 46. That doesn't work because that gives me 106. Remember, I'm trying to get 90, right? If I'm saying 60, I'm adding a special angle with one of the angles of the triangle. Okay. What about if I say 45 plus 44? Okay. 45 plus 44. Okay. I'm getting 89. Doesn't work. Very close to 91, but doesn't work. And in this case, you could try subtraction, like maybe 46 minus 45, but this gives me 1, right? Subtraction in this case is most likely not going to work because this is a big value, right? So I don't think there's 2 things you can subtract to even get close to that value. So we're going to keep trying to add. So obviously 60 was too high. So let's try 45 plus 46. And that actually works. When I say 45 plus 46, I get 91. So that's actually how they got it. So here, this is a special angle. And this one is actually an angle from the triangle. Let's do this a bit neater. Okay, an angle from the triangle. So again, adding or subtracting special angles with angles of the triangle. This one could get a bit like random, because then they could add any special angle with either one of these two, and there's a lot of possibilities. But again, it is a possibility. And sometimes, like, use your logic to see, like, again, like I said, you can't subtract in this case because 91 is a big number. You're most likely not going to be subtracting a special angle with any of these triangles to get 91, right? So that narrows it down for you. You just start adding. And then obviously 60 plus 40, that's 100. So if you're going to add 60 and 46, it's going to be too big. You're going to get to 91. So in that case, that's how you can use your discretion, okay, to not like waste time to try all the options, okay? So 46 plus 45 actually works. So we can re-express this as sine, it doesn't matter which one you put first because it's addition, sine 46 plus 45. And again, this is compound angles. This is not reduction. So again, compound angles, this would simplify to sine 46 times cos 45 plus cos 46 times sine 45. Okay, and we can simplify this again. So this we're going to get from the triangle, but this is a special angle, so we know its value, right? So sine 46 I can get from my triangle. Sine 46 is square root of k over 1 minus k squared over 1. Okay, times by cos 45 is 1 over square root 2 or square root 2 over 2 plus cos 46, again triangle. Cos 46 is k over 1. So this becomes k over 1 times sine 45 has the same value of cos as cos 45. Square root 2 over 2. Okay, now we simplify, we multiply our numerators and denominators, and then just simply add it to the next multiplication, numerators, denominators. Okay, so in this case, we get, again, remember, when you multiplying two square roots, you multiply the two terms inside. So this becomes 2 times 1 minus k squared, all inside of the third, divided by the denominator, which is 2, added to, this would be k times root 2 divided by 2. Let's simplify this further. Inside of the third, I'm getting 2 minus, or you can actually leave it like that. Please, you can't cancel these because one is inside of a third, one is outside of a third. Okay, you can leave it like that, or you can simplify to 2 minus 2k squared divided by 2. Okay, because they actually have the same denominator, you can just simply add it here. K times root 2 all over 2. Okay, so yeah, this is a very complicated example. Sometimes they'll probably, let me just see that I do everything right. Okay, and I use in terms of, yeah. So yeah, okay, it's a complicated one. There's the possibility of it coming out, but sometimes they like to give ones where the answer simplifies. Like obviously I just made up this example, so that's why the answer wasn't like so nice. Okay, but you might get a nice answer in the exam. But nevertheless, the concept is there. Adding or subtracting the angles of the triangles with special angles, and thereafter doing compound angles, thereafter simplifying it and simplifying it to get that value. Now let's have a look at this last one. Okay, this last one has cos 14. So this example is another one of the last ones, okay, of subtracting or adding angles of triangle with special angles. So let's try like 60 minus 44, and that works. So I can re-express this as cosine special angle 60 minus angle from triangle 44. And I haven't changed the value because this is still cosine 14. Now I use compound angles. I say cos sine 60. Okay, cosine 60 times cosine 44 plus sine 60 times sine 44. Okay, so this is how you simplify the cos compound angle. Cos 60, okay, that's a special angle. I know the value of cos sine 60. Okay, cos 60 is cos 60 is 1 over 2. 1 over 2 multiplied by cos 44 that I get from here. That's square root 1 minus k squared over 1. Plus sine 60, I know the value of the special angle. That is square root 3 over 2 times sine 44, that's from the triangle, k over 1. Simplify this further, we get square root of 1 minus k squared over 2 plus k times root 3 over 2. Put it all under one fraction over 2. And we have the square root of 1 minus k squared plus k times root 3. Okay, and that's our final answer. Again, these are complicated examples, so the answers are not, they're not nice. Okay, they're weird, complicated, and again, there's no way of simplifying this further, right? You don't want an actual value for this answer. You just want everything in terms of variables. So this answer is perfectly okay. Can your teacher wouldn't be too strict about the final simplification? I don't think. Just because like the main marks you're going to get is for all of this. Okay, so just keep that in mind. But yeah, maybe what I'll do is I'll neaten these notes up a bit so that it's not so jumbled and it's not so in your face. Just keep in mind that these two last ones, these are to do with compound angles. Okay, so yeah. Okay, cool. Let's end it there slightly early, 1 minute early. But yeah, I hope you guys understood in terms of questions. Okay, there is no need to, you guys should practice, right? There's no possible example that is not done basically here, right? It's not you don't have an example to sort of rewatch the video. I mean, you'll have an example to rewatch the video of a certain question that could be the same as any other question you could solve. Okay, so yeah, I'm just trying to think. So yeah, in terms of questions, right, with all the possible different ones they could ask you, so do some practice questions, practice some examples of these type of things, and you'll see, right? A lot of times they're not asking the like C, D, E, or F, or G. Maybe it's like A or B. Okay, but at times you will also see those other examples. Okay, cool. So let us end it there. Okay, I will see you guys next week, where we will continue with trig. I know we're going a bit slow, but we're gonna try and catch up, right? In the holidays, we'll probably have some extra classes just to catch up so that by term 3, hopefully we can try and be on par. You guys have 3 topics, which you probably, most of you are maybe done by now. Euclidean, analytical, and functions, I believe, or calculus, right, which we're going to hopefully get there. So yeah, apologies for the delay. Obviously, we did start late in the year, and then we do take our time with certain topics, but we will get there. And I hope you guys either way are benefiting from these lessons, and it's improving these certain topics that even maybe you've done in term 1. Okay, but nevertheless, let us end it there. Thank you guys so much for joining. I will see you guys next week. Have a good rest.